Hi class, in this video we're going to be talking about solving equations with variables on both sides. So here I have a visual representation for you where I have a seesaw or a teeter-totter. Since they are in balance right now, they are equal to each other. So let's write this out. I have I have two x's on the left-hand side, and I have 4 circles. So I have 2x plus 4 on the left-hand side. On the right-hand side, it looks like I have 7 plus 1x, right? So I can either write this as 1x or just write it as x. Now in this case, I have to ask you this question. What's bigger, 2x or x? 2x should be bigger than x, right? So what we want to do for a consistent method is I want you to take away the variable from the side that is not bigger. So in this case, because x is smaller than 2x, I'm going to start by taking away x from both sides. And the reason I take away x from both sides is this. If I take away x on the right-hand side and I don't do anything to the left-hand side, now all of a sudden I'm not in balance. The left-hand side would just weigh itself down on this seesaw or teeter-totter. But in order to keep them in balance, if I take away x from one side, I have to remove x from the other side. So right now I'm taking away x from both sides. So now I'm going to, once I take the x's away, it looks like what I have left is going to be just 1x, because 2x minus x, or 1x, is just going to be x. So now I have x plus 4 on the left side. And on the right side, all I have left is 7. This is just a one-step equation now. So now I'm going to take away 4 from my left side, but if I take it away from the left side, I have to also take it away from the right side for it to be in balance. So now I have x on one side, and the other side I have 7 minus 4, which should be 3, as you can see with the visual here. So hopefully that visual helps you out. And now we're going to move on to solving these equations with variables on both sides without the visual representation. So now I have just the equation with no visuals. 5a plus 8 equals to 3a plus 18. So again, our rule should be to take away the variable that is the smallest. So in this case, what's bigger, 5a or 3a? Well, 5a is bigger, right? So I'm going to take away 3a from both sides. So because 3a minus 3a is going to be 0, I don't have to worry about the side, the right side now. All I have on the right side now is just 18. 5a minus 3a would be 2a. So now I still have 2a plus 8 on the left side. So now I have a two-step equation. 2a plus 8 equals to 18. So now let's isolate for a by using reverse BEDMAS or SAMDEV. Now I'm going to take away 8 from both sides. I'm just going to get 2a on the left side now. On the right side, I have 18 minus 8, which should be 10. Now I have a one-step equation. I'm going to isolate for a. Right now, 2 is multiplying by a. So to get just a by itself, I'm going to divide both sides by 2. Upon doing so, a is on the left side. Now on the right side, I have 10 divided by 2, which should be 5. So a equals to 5 is my answer. Is there a way to check if I've done this right? Absolutely. You can always check your work, right? So again, to check your work, what I can do is take my equation, replace a with 5 instead. So now this is going to be, instead of 5a, 5 times 5 plus 8 on the left side. Now on the right side, I have 3 times 5 plus 18. So now let's see if the right side equals to the left side if a equals to 5. 5 times 5 is 25, so I have 25 plus 8. 3 times 5 is 15, so I have 15 plus 18. 25 plus 8 is 33. 15 plus 18 is also 33. Since the left side equals to the right side, I can say yes, a does equal to 5. Okay, let's try another example here. So for this question, I have variables on both sides. Once again, which is greater though, 2z or 6z? 6z is greater, so I want to take away the side that is the smallest. So because 2z is the smallest, I'm going to take away 2z from both sides. Okay, so now I just have 10 on the left side. Now on the right side, I have 6z minus 2z. That should be 4z. So I have 4z minus 18 on the right side. Now this is once again just a two-step equation. I'm going to isolate for z. So I'm going to add 18 to both sides because I'm applying reverse BEDMAS. So I want to do my subtraction or addition first. So I add 18 to both sides to undo the minus 18 here. On the left side, I now have 10 plus 18, which is 28. On the right side, all I have left is 4z. Now, I want to get z by itself. Since z is being multiplied by 4, I have to do the opposite and divide by 4. Now on the left side, I have 28 divided by 4. That's going to be equal to 7. And on the right side, all I have left now is z. So z equals to 7 is my answer. Okay, let's move on to our last example. So in this last example where I have a variable on both sides, it looks like I have 2x on the left side and negative 3x on the right side. Now let's ask the question again. What's greater, positive 2 or negative 3? Well, positive 2 is greater, so I want to get rid of the negative 3x then on the right side. So right now, since it's minus 3, the opposite of minus 3, I'm going to apply the opposite, would be plus 3. So I'm going to add 3x to both sides. Now, would you agree that minus 3x plus positive 3x is 0? Absolutely. So that means all I have left on the right side now is just 9. Now on the left side, I have 2x plus 3x. That should get me 5x. And then I still have to subtract the 21. So now I have a two-step equation where I have 5x minus 21 equals to 9. Now let's isolate for x and solve. I'm going to apply my SAMDEV here, reverse BEDMAS. I'm going to add 21 to both sides. All I have on the left side now is 5x. On the right side, 9 plus 21 is going to be 30. Now I'm going to divide by 5 because I have 5x, and that means 5 times x. So by dividing by 5, I just get x by itself on the left side. What I do to one side, I have to do to the other. So 30 divided by 5 is going to be 6. So my final answer is going to be x equals to 6.